to go over horizontal and vertical lines and target 9, which is parallel or intersecting lines. The video is going to follow the handout, so make sure you have the handout in front of you. Let's start with target 8, which is horizontal and vertical lines. The first thing I would like you to do is take some time and plot these points. So I'd like you to plot the point 4, 2, negative 3, 2, 1, 2, and negative 5, 2. And when you're finished, I'd like you to plot the points 1, 5, 1, 0, 1, negative 3, and 1, 2. So go ahead and do that now. Hopefully you've had a chance to plot them, so let's look at number 1. What happened when you plotted the points is that all of the points, if I were to connect them, fall on a horizontal line. And the slope of a horizontal line is 0. Notice when I have an intercept, it only has a y-intercept. It does not have an x-intercept. What I'd like you to notice about this is if you look at the points, all of the points have a y value where the y value is 2. And so when you have the same y value, it actually creates a horizontal line. So if those are horizontal lines, then this side are vertical lines, where if you were to plot the points, all of them have an x of value of 1. That creates a vertical line. When you have vertical lines, the slope is undefined. And in this situation, the x-intercept is 1. There is no y-intercept because it does not cross the y-axis. So using that information, could we then apply it to the equation of horizontal and vertical lines? So I'd like you to graph the line y equals negative 1. Notice in this equation, you're missing the x, which is the slope, and you're missing the y-intercept. Okay, so what would the equation of y equals negative 1 be? Y is always negative 1. So it doesn't matter what my x value is, y is always negative 1. This creates a horizontal line. Horizontal lines have a slope of 0, and the only intercept it has is a y-intercept of negative 1. So if I ask you to graph a horizontal line, they always take on the value y equaling a number. It can be any number, but when you're missing everything else in the equation, it's one of the special cases. So notice number 4, this is the only equation that doesn't even have a y. It just has an x. It's saying x is negative 3, and x is always negative 3. So x is always negative 3 creates a vertical line. And then vertical lines have undefined slope. Undefined slope. And then the equation of, or the x-intercept, it only has an x-intercept at negative 3. Okay, so all equations, whenever you have x equaling a number, those are always going to be vertical lines. So if I ask you to write the equation of a line that passes through this point and has an undefined slope, well, if you think about it, undefined slopes implies that it's vertical, and so the equation of this line would be x equals a number. So your answers in this section are either going to be x equals a number or y equals a number. And because we want a vertical slope, that means I have to use the x value of this point. And what's the x value of this point? It's 4. So that's why my equation is x equals 4. Number 6 says write the equation of a vertical line. So same thing that passes through this point. If you have a vertical line that goes through that point, that's going to be x equals negative 3. If it had said write the equation of a horizontal line, then it would be y equals negative 2. So it's just one point or the other. Lastly, number 7 says write the equation of the line that passes through these 2 points. So one of two things. If you are doing this on a test, you could just find the slope between them. And the slope is either going to be 0 or undefined. But if you think about it, both of these have an x value that are the same. And so when your x value is the same, that means x is always that number. So again, you have x equals negative 4. And that's target 8. It's either going to be x equal a number or y equals the number. Flip your paper over, and this is target 9. Okay, so I'm going to give you a second to graph these lines on the same plane. So notice it says y equals 2x minus 5. So what that means is you're going to start at negative 5, and then you're going to move off of that point by going up 2 over 1. And to graph the second line, you're going to start at 1, and you're going to go up 2 over 1, up 2 over 1. And remember that you need to draw 3 points in order to connect them. So your graph should look like this when you're done. And notice these are what we call parallel. I'm going to give you another second, and I want you to graph these two. So in this case, you're going to start at 4, and your slope is negative 1 over 2. So you're going to go down 1 over 2, down 1 over 2. And the second equation, you're going to start at negative 3, and your slope is 1 over 1. So you're going to go up 1 over 1, up 1 over 1. And when you're done, your graph should look like this. So in one of the cases, these are parallel. In the other case, it seems to intersect. So how could we know that without having to graph? And that's what I want you to get out of this, is if I were to graph it, it's easy to tell, but how can I know that without graphing? So if you think about it, if I were to just randomly start drawing 2 lines up here on the same graph, what would happen? So we just saw one thing is that I could draw 2 lines and they could never cross. Or I could draw 2 lines and they could intersect. Is there anything else that could happen? What if I drew a line and then drew the exact same line on top of it? Okay, so those are your 3 possibilities. The first thing that could happen is they could be parallel. Okay, parallel lines have the same slope. So what I want you to look at this is a 2x and this is a 2x. So just by looking at the equation, if they have the same slope, then they're parallel lines and they're never going to cross. Okay, if they're going to intersect, then they have to have some different slope, and it could be anything. It could be a positive and positive, it could be a 3 and a 4. These slopes just have to be different and they will intersect somewhere. Okay, and then the last thing that could happen is they could be the exact same line, which would be easy to tell because they would have the exact same equation. They would have to have the same slope and the same y-intercept. Okay, so now reference your notes, number 9. It says write the equation of a line that is parallel to this that passes through this point. So I'm actually going to use point slope form because I have information about a point and I have information about the slope. So if you can recall, point slope form looks like this: y equals m times x minus x1 plus y1. So if this is the equation that has to be parallel to, parallel lines have to have the same slope. So I'm going to use this slope of a half. So my new equation is going to be y equals 1/2 x parenthesis. Sorry, I forgot that. And then since my point is 4, negative 9, I'm going to do minus 4 because the inside has to change, and then plus 9. And I can leave it like that. So the only key is I needed the slope from here and I needed this point. Number 10, write the equation of a line that would intersect. If they are going to intersect, that means it has to be something other than a slope of 3. Because if it had a slope of 3, then they would be parallel. So it's got to be anything besides 3. So pick something. So I'm going to write y equals, I'm going to pick negative 2 times x minus nothing plus 4, because it's got to go through this point of 0, 4. And you could simplify that if you want, but you don't need to. So lastly, number 10 or 11 and 12 is asking you, given this representation, line 1 and line 2, are they parallel or intersecting? So if they're parallel, their slopes have to be the same. If they're not the same, then they're intersecting. So let's look at the slope of a table. So in this case, I'm going from 2 to 1, 1 to 0, which means I'm going down 1. And over here, I'm going 6 to 3, 3 to 0, 0 to negative 3, means I'm going down 3. And so if I reduce that into change of y over change in x, I'm doing negative 1 over a negative 3, which really reduces to positive 1 over 3. And then if you look at line 2, the slope is right here, which is 1 over 3. So they're the same. Therefore, these two lines are parallel. Okay. Over here, the slope of this line is negative 3/4. We have to find the slope of this line. So I'm going down 1, 2, 3, and I'm going over 1, 2, 3, 4. But I'm starting at, so this is a slope of negative 3 over 4, but I'm starting at 1, 2, 3 as my y-intercept. So these two lines are the exact same line, not intersecting. Okay, so parallel lines have to have the same slope. Intersecting lines have to have different slopes. So if this graph had been going like up to over 5, then they would have been intersecting. You could also prove this if you wanted to graph this on this plane, then you could literally see if they were the same or different. Okay, and that's target 8 and 9. They're similar, but slightly different. Okay, so now you know about horizontal vertical lines, and you know how to tell if two things are parallel or intersecting.